to this Snack and Learn webinar. Today we will hear a little bit about reuse of construction and demolition waste. My name is Katrine Jensen. I'm from VSP in Denmark, and I want to start by introducing you to the team that I'm a part of. As I just said, we're situated in Denmark, and we are part of the Earth and Environment Division and part of the Department of Environment, and our team name is Demolition and Reuse. We are 12 people working with the following services: mapping of contaminants, mapping of resources. We make plan for resources. We make tender materials in relation to demolition, and we also touch upon HSE, teaching, guidance, and presentations. We are actually part of what is called the VCUB. VCUB is a center that we run together with the Danish Technological Institute. We aim to collect, present, and distribute knowledge on different items within this demolition, reuse, recycling, and circular economy. The purpose of the presentation today, well, this Snack and Learn webinar will give you an overview of how we target the reuse of construction and demolition waste in Denmark on a general basis. We will also try to illustrate a little bit how we work to secure as much reuse as possible by presenting some of the core services in that relation. So I will not dig into a specific project, but if you are interested in hearing about a specific project where we work with reuse and recycling, I will recommend that you listen to the Snack and Learn webinar the 1st of December that my colleague Marlene Thormann is giving. She will tell you about a specific project. Today we will more give an overview of how we work with the reuse and recycling in Denmark. So the agenda today is I'll start by telling you a little bit about what is construction and demolition waste. Why is reuse of construction and demolition waste such a big focus point in Denmark? And a little bit about the core services for VSP in Denmark in relation to reuse of the construction and demolition waste. And then I'll give some brief examples of projects where we have been integrating reuse of construction and demolition waste. And as Sharon just said, there will be a Q&A session at the end. First of all, what is construction and demolition waste? Well, in general, construction and demolition waste is generated when we demolish buildings. So what you can see here in the pictures, we have some buildings which are being demolished, and as soon as they have been demolished, we have construction and demolition waste. And the reason why we need to reuse construction and demolition waste, well, the first reason is that we have a lack of resources. As you can see to the right, in Denmark, we actually use much more resources than we should. We use more than 4 planets every year. And 40% of all the reuses we use in Denmark is used in the building sector. The second reason why we have a focus on reuse of construction and demolition waste is that we produce way too much waste. In Denmark, more than 5 million tons of construction and demolition waste is produced every year. And that actually equals more than 40% of all waste produced in Denmark. And it also equals like 150,000 trucks that drives around with construction and demolition waste every year. The last reason is that as many of you have heard, and which is also being talked a lot about in Egypt this week, we have climate change and high emissions of CO2, and in Denmark, 20% of the CO2 emissions actually comes from the building sector. So what we need to do is that we need to leave this linear model behind us. Today, we often use this linear model where we produce, we use, and we discard. And why we do it this way, we use many resources, we produce a lot of waste, and we have high CO2 emissions. So instead, we need to adapt this circular model. When we use the circular model, we have to the upper left, we still have exploration of virgin materials, which goes into a fabrication of construction parts to the building face, and we have the buildings in use. And when we come down here, at some point when the building is not going to be used anymore, we have the demolition part. But what we do different in this circular model is that we try to reuse as much as we can. For instance, the bricks and the windows, which is illustrated here. And what cannot be reused is recycled. The recycling parts is the parts from the buildings that cannot be reused right away. We need some kind of processing, but when we process it, it can actually go into the fabrication step instead of virgin materials. So this is basically the linear model that we're working with. When it comes to the sustainability goals, of course, we're tapping into goal number 12, which is responsible consumption and production, and also goal number 13, which is climate action. And I have also added goal number 14 and 15 because when we produce less waste and we exploit less materials, then we will also affect the nature less than we do now. And what services does our team focus on? Well, we are at the bottom of this model. It's about demolition, it's about reuse, and it's about recycling. So basically, in the demolition phase, we have these services over here. We have mapping of contaminants, mapping of resources. We have plan for resources and waste, tender material, and surveillance during demolition. The mapping of the contaminants, we have done that for several years in Denmark, at least 10 years. The mapping of the resources and the plan for the resources is quite a new thing. And I will dig a little bit into these services to tell what it is that we do. The process is that we start by mapping contaminants like we always did, then we add the mapping of the resources, and based on the mapping of the contaminants and the resources, we try to make a specific plan for the resources, and then we integrate it in the tender material, and then when the contractor is doing the circular demolition, we are checking out that they do it the way it should be done in order to ensure the resources. If we start by talking a little bit about what is it we do when we map contaminants, well, we have a focus on substances that we suspect might be present in the building. It's PCB, it's chlorinated paraffins, it's asbestos, it's different heavy metals, it's tar products like PAHs, it's hydrocarbons mainly. We also have a focus on building parts where we suspect that the substances might be present. This means that we know that substances is used in different parts of the buildings. And finally, we have a focus on the age of the building and also the time for renovations, because a number of the substances has only been used in specific years. This is quite important knowledge when we want to find out where in the building do we have these contaminants. So this is in Danish, but I just wanted to show you anyway, because what we have here is for asbestos, for instance, and it's just a screen dump of a long list. We actually have a list where we, for type of material, type of products, have a list of periods where the asbestos has been used. So this helps us a lot when we are looking for the asbestos in the buildings. I added some examples of our sampling. This could, for instance, be taking samples of old floor tiles and including the adhesive. It could be taking samples from isolation around pipes. It could also be taking samples from these roofs you see here, which often contain asbestos. When it comes to the PCB, here are some examples of what we would be sampling. PCB is often found in paint and maybe especially in the heavy walls. We found PCB in these soft caulkings in joints. This is also the joint you see over here. And then we find PCB in oil in condensators. And these condensators, which is actually here, can often leak, and then we can have PCB all over the building. For the metals are in all types of paint, both paints on wall, paints on floors, and paints on boards. But we also find it, for instance, in old linoleum, and we can also find it in lacquers on floors. When we have collected all our samples, we send them to a certified lab, and they analyze it. And then we make a report, and I'm not suspecting that you can read all of this, but it doesn't matter. I'll tell you. This is the sample numbers we have down here, and then it actually describes which building is the sampling from, where was the sample collected, what kind of construction, what material, what color, and then we have pictures over here. And right here we have the results from the lab. And the red one shows that it's hazardous waste, the green one that it's clean, and the yellow one that it's contaminated. And this is quite important also with the pictures, because the contractor needs to know where are the contaminants so that he can remove it before he tears down the building. This one also adds to this because we also need to have a drawing showing where we have been taking the samples. So it also helps to know where do we have the contaminants in the building. On top of this, this mapping of contaminants, we also started mapping resources in different projects. And this is one of the projects. It's Vridsløselille State Prison. The prison is the star you can see in the middle of the picture, the star building. It has the shape of a star. And then it has also the large prison wall around it. And this is going to be turned into a residential area. So they need to tear down most of the buildings, and the hope is that they can use a lot of the resources from these buildings in the new buildings at the site. So when we do the mapping of the resources, the first step and very important step is to clarify with the project owner what the exact purpose of the resource mapping is. In this project, we need to map not the red buildings, as you can see over here, because the red buildings are actually going to stay at the site. So we needed to map the rest of the buildings to find materials. And we needed to make a catalog of possibilities in relation to reuse. The second step is actually a desktop study. We try to get an overview of the buildings in terms of the size, the age, the materials, as it can be deducted from drawings. Then we move on to the field registration of the resources. We have an Excel spreadsheet on a tablet when we go out into the field. And then we focus on, for instance, the large fraction. In this project, we have all the timber. We had more than 8,000 meters of timber. And we have the bricks over here. We had more than 5 million bricks in this project. But it can also be some of the rare things, like the floors here in the middle and these windows, which can be valuable in the project. So in the report, we make a brief discussion, of course, a description of purpose and methods, and we also try to make a description of the findings, and we divide it into materials. For instance, timber. How much timber do we have? What is the general condition of the timber? Is it contaminated, which means it should be cleaned before it could be reused? What can it be used for? And is it necessary to possess the timber before we can reuse it? So as a part of the report, we have this Excel spreadsheet. Now you only have 10 rows down here, but actually we had more than 250 observations in this project. And what you see is that we have what part of the building is it, what is the material, what building is it, it's the roof, what room is it, how much do we have, what is the condition, and then we link it to the mapping of the contaminants also, and then we try to give just a brief comment on how to handle it during demolition and what it can be used for. And then the next step in the project, when we have the mapping of the resources and the mapping of the contaminants, is actually to make a specific plan for the resources. We need to transform it so that it can be used in relation to the new project at the site. And we do that together with the architect, with the project owner, with the municipality, with the contractor who's going to tear down the building. So it takes a lot of work together. And what we want to do, for instance, with the windows, we try to describe, do we want to use them in the new buildings? In that case, what would it take? And potential estimate of economy, and maybe also even the CO₂ emission. And if we talk about the timber, do we want to use some of the timber in the new project? What could it be used for? Then we, for instance, when it comes to the timber, we could talk to these firm called Neste. They produce sheds. They could maybe produce sheds for us at site, or we could talk to today, Lena Genbyg is called again. It's a firm that makes these indoor panels. They actually cut off the timber and make indoor panels. So we need to look out and see what options do we have when we want to reuse and recycle. When we have the plan, then we need to make sure that it's in the tender material for the demolition project. We make circular demolition, and the following step is to be included when we make circular demolition: disconnection of supply lines, removal of inventory, environmental remediation, which should be done in line with the findings of the mapping of contaminants, and then we have removal of sorting of non-supporting structures, and then demolition of supporting constructions and removal of foundations. And in all these steps, we need to make sure that they take out the materials in a way that it can be reused and recycled. For instance, with the bricks, it's much easier for them to demolish if they don't need to reuse the bricks one by one. So we need to describe that you need to take down the building so it can be reused. Just a short example here. This was a project where we used actually all of these services I have mentioned. The original buildings, as you see on the picture, originally it was actually a stocking factory, and then in the 70s it was turned into a school, and then in 2016 our client Bonava Denmark decided that they want to make it into a residential area. So what we did was mapping of contaminant, mapping of resources, and then adding it to the tender material. And then when the contractor started to tear down the buildings, we started by checking the remediation. We actually take samples after they have cleaned the surfaces for paint and so on. Then we take samples to make sure that the surfaces is actually clean. We also check the circular demolition. Are they sorting the materials and handling the materials the way they should? And just some pictures, you can see here that they are crushing down concrete and asphalt at the site. They actually also ended up crushing down the bricks because when we started to check out the bricks when they took it out the buildings, we found out that they were in really poor condition, or much poorer than we could actually see when we were just looking at the walls before we were tearing it down. So instead, the bricks also was part of the things we were crushing down, and all in all, we had approximately 8,000 cubic meters less waste to be transported away from site, and also we had 8,000 cubic meters less materials to be transported to site, because this can be used instead of virgin materials like gravel. And down here you see the new buildings, and you can also see why we were hoping we could have used these yellow bricks instead of using new yellow bricks. And just some key takeaways. We need to use the circular model to decrease the amount of waste, the use of resources, and the CO₂ emissions. Mapping of contaminants and resources in the building is quite essential for this process. And then it's important to turn the mapping of contaminant and resources into a very specific plan for the materials. It's important, we found out, to keep track of the process from the beginning to the end. Often now the project owner is hiring us as a environmental and resource coordinator throughout the project, and that really helps. Reuse and recycling of construction and demolition waste requires a high degree of collaboration between authorities, project owner, architect, contractor, and the consultants, which is us. And that's why early planning is quite essential if the project is going to be good. Yeah, I think that was it.
Thank you, Judy, for a fantastic presentation. So just again to remind everyone, the housekeeping items. So the presentation is available to download as a PDF in the handouts on the control panel. And also we already received some fantastic questions, but you can still log your questions in the question box on the control panel. I will start with the first question. In your opinion, what are the major obstacles when we wish to reuse or recycle construction and demolition waste?
Well, unfortunately, there are quite many of them. This is a whole new way to do the things. we have done it, and the way we did it, we have done that for so many years. Now we need to rethink the process, actually. We have legal restraints, actually, in Denmark. Yeah, it's actually made so that we should use new materials. It's really a shame, but that's the way it is. It is changing, but it's not. It hasn't changed yet. So we have some legal restraints. And then actually we also see in many cases that this is more expensive than doing it the normal way. So that's also something that is holding it down. And then we have something about the responsibility. When you use some of the materials again in new buildings, who's going to take responsibility for the materials? When you use new materials, you have the ones who are actually making the materials. They take the responsibility for the reuse of the materials. But that's not the case when you have reused materials. That's also one of the things we're struggling with. Yeah, I think that's.
Thank you. There's a question here about lead. If you find lead as a component of paint, how do you treat it? Do you remove, let's say, if it's a paint on a handrail, do you remove all the handrail and then send it to recycle, or do you remove the paint, basically?
If we want to, yeah, that's actually a good question. If it's on a wall, we would just remove all the paint, and then the wall would be considered clean. We would take a sample, and it would be considered clean, and we would have the concrete or whatever would be clean. If it's a handle in a staircase, for instance, then it would be a little bit different, because if you use it again as a handle, we actually don't have to remove the lead. But if we need to use it for something else, then we have to remove the lead before we use it.
Thank you. The next question is, in Denmark, is there a reuse buyer or supplier for when there is no specific plan for the reuse of materials or intent for reuse with no source?
More than more, I think. It has been a problem. It has been a problem both with the supply, but also to sell your materials, or to get rid of the materials. Yeah. But it gets more and more often, and there are actually web-based places you can get rid of your materials. And we also have companies who can come out and look at your building before you tear it down, to give an estimate on the things that they would actually like to have. Often it won't be that they buy the things; they take it for free, and then they can probably sell it.
Thank you. Just if you can go back to one slide, I think, so we can see your contact details. Something happened.
Then I just have to. Yeah, I don't know. I'll just do it like this.
Yeah,
Okay.
perfect.
Yeah.
The next question is, how do you work with governance to integrate this process in the regulation?
Yeah, actually, I worked at the Danish EPA like 8 years ago, and we started the process back then. But it is a tough process, and it's different. We have the Danish EPA, but we also have other parts of the system who needs to work together, because the Danish EPA is handling the contaminants, and then you have the another part of the Danish ministers who are handling the new buildings. So they need to work together. I think it is moving, and there has been instances to make it better. And from next year, actually, we would have a maximum limit on CO2 from the buildings, and that would also increase this. I think it would be better to reuse and recycle when we are not allowed to emit as much CO2 from the building process. But there's still some way to go, I think.
Thank you. The next question is, are targets set for overall project or by materials?
I think you need to say that again.
Are the targets set for the overall project in terms of reuse, or is it by material?
It can be both. If we have a site where when we tear down the building and we can reuse it at site again in the new residential areas, for instance, we would focus on the new project. But the things we cannot reuse at site afterwards, we would go material by material and say, what can we do with it off-site? Does anyone wants to have the wooden part of our buildings? Does anyone want to have our bricks? Yeah, and so on.
Thank you. What things can governments do to encourage more reuse of construction demolition waste?
Well, I think there are two ways to go. One thing is that they remove the legal restraints, but other than that, I think they can give money to the people who do this. And the other thing is that they can do like they do now. They can have a tax on CO₂ emissions, which will also come in Denmark, which will make it more expensive not to reuse and recycle. Yeah, so that's two different ways to go, I think.
Thank you. So we have a lot of questions coming through. Next question is, what is the communication plan with the crew that is doing the demolition? If you can walk us through the communication plan.
Yeah, because that's also a
general.
really good. Yeah, it's a really good question because it's really not easy. Of course, they have someone who is in charge of the teams out there, and basically it's there. Yeah, they need to take care that it has been communicated down towards the teams, throughout the teams. We have meetings every week at site. One meeting at the beginning where everybody should participate and where we talk about reuse and recycling in general and why it is important to reuse and recycle. And then we have weekly meetings with some of the team leaders out there. Yeah, and then it's also very important to, for instance, mark on the different containers at site where they should put down all the different materials and how it should be sorted. But to have meetings on a running basis is very important, and to follow up if it's not how you suspected it should be. Sometimes we have also been having meetings like 3 times a week because it didn't work out the way we wanted it to work out. So we need to be very much at the site.
Thank you. I will take the last question, and I really will follow with all the remaining questions that were unanswered via email. So the question is, how can you demonstrate if a material that you aim to reuse has the right characteristics for the new use? Do you test it? And for example, this person is thinking of a steel beam or a steel frame.
Yeah. We try not. I would say we try not to use it in some of the bearing constructions because that is really difficult. As I was also saying before, who's going to take the responsibility for this steel beam? It might even be that we quite well know that it will be okay, but we still need somebody to take the responsibility. If we have many steel beams that are the same and has been used for the same in the former building, we can actually test some of them, but we cannot, of course, not test them all because when we add pressure to the beams, they will at the final end, they will bend when they have reached what they can actually bear. So we can only test like 1 or 2 of them. So we only test them basically if there's many of them. Otherwise, we really try to minimize reuse and recycling when it comes to the bearing parts of the building.
Thank you for clarifying this. Fantastic. Thank you, Julie, for a fantastic presentation. And thank you, everyone, for joining this webinar. And thank you for the wonderful questions we received. Really impressive. So please feel free to follow up with the presenter via the contact details shown on the screen. And I wish everyone a wonderful day. Thank you for joining. And I will share with you all the details for the upcoming webinar with the experts from Denmark. Thank you so much.
Thank you.